This video lesson is about solving systems of equations by substitution. So to review, a system of equations is two or more equations that have two or more variables that we're going to solve to find that ordered pair that satisfies both of the equations or all three of the equations. We are looking for an x and a y pair, ordered pair, that is going to make both of these equations true. So the word substitute means to replace. So I see here that y is equal to 6x minus 11. So anywhere that I see y, I'm going to replace it with 6x minus 11. So the second equation becomes negative 2x minus 3 times 6x minus 11 equals negative 7. So all I'm doing is substituting 6x minus 11 right in here where the y would be. I see I have distributive property. So negative 2x, negative 3 times 6x is negative 18x, and negative 3 times negative 11 is positive 33. I'm just going to combine like terms and continue solving. So negative 2x minus 18x is negative 20x. Subtract 33 from both sides. And negative 7 minus 33 is negative 40. If I divide both sides by negative 20, then x is equal to 2. Now that's only the x value of my ordered pair. I have to go and find the y value. So I'm going to go back up into either of the equations, and I'm going to substitute in a 2. So the top one looks easier to me since it's already solved for y. So I have 6 times 2 minus 11. 6 times 2 is 12, and 12 minus 11 is 1. So now I'm going to check and make sure that both of these numbers, x and y, both satisfy both equations. So this first one is 1 equal to 6 times 2 minus 11. Yes, that works. Substituting 2 in for x and 1 in for y, negative 2 times 2 minus 3 times 1 should equal negative 7. Well, negative 2 times 2 is negative 4. 3 times 1, negative 3, negative 4 minus 3 is negative 7. Yeah, it works. So what does this mean on a graph? If I were to graph both of these equations, my two graphs would cross at the point 2, 1. That's my intersection point. All right, let's try another one. So it looks like on this one, my bottom equation is the one that's solved for y. So I'm going to substitute that in right there for this y. So negative 3x minus 3, then we have negative 5x minus 17 is equal to 3. So again, I am substituting the y for what y is equal to, negative 5x minus 17. Again, distributive property. So I have negative 3x, negative 3 times negative 5x is positive 15x. And negative 3 times negative 17 is positive 42. Combining my like terms, negative 3x plus 15x is 12x. Subtract 42 from both sides. I didn't do that right. That was 41. 3 times 17, that's 21. 51. Whew, really off. Sorry. All right, back to business. So 3 minus 51 is negative 48. And then divide both sides by 12, and x is negative 4. We're going to substitute that back in to find my y value. Again, I think the bottom equation is going to be easier because y is already by itself. So negative 5 times negative 4 minus 17. Negative 5 times negative 4 is 20, and 20 minus 17 is 3. So that makes my ordered pair negative 4, positive 3. So since I had that whole mix up with 3 times 17, let's just check this answer and make sure I got it right. So let's try this top equation. This is my x, this is my y. So is -3 times -4 minus 3 times 3 equal to 3? So that was my x, that was my y, just substituting in my equation. So that's positive 12 minus 9 is 3. Yay, it works. This bottom equation is 3 equal to -5 times -4 minus 17. Yes. All right, what do we do if we don't have one of the equations solved for our variable? Well, we solve it. So if I look at this top equation, much easier to get my y by itself than anything else, because y has a coefficient of a 1, so not too bad. I'll just add 5x to both sides, and y is equal to 5x minus 2. Substituting 5x minus 2 in for y, and I'll distribute. So this is -3x plus 30x minus 12 equals -12. Combining like terms, that's -27. No, that's positive. 27x minus 12 equals -12. Add 12 to both sides. Oh my goodness. 27x is equal to 0. Divide by 27, and x is 0. You're allowed to get 0 as an answer. Don't let it scare you. Plugging a 0 back in. Again, I can go anywhere I want, so I'm going to use that top equation. -5 times 0 is 0, so y is equal to -2. Checking my work, I'm going to plug this. This is x, this is y. Plug that back into my bottom equation. -3 times 0 plus 6 times -2 should equal -12. Well, that's 0. 6 times -2 is -12, and that works. All right, I've got 2 more for you, I think. Yeah. On this next one, I think this y is what I'm going to get alone just because it's positive and this x is negative. So I don't want to be left with a negative x. I want to be left with a positive. So if I add x to both sides, then I have y equals x plus 3. Substitute that in here. If y is equal to x plus 3, then x plus 3 goes in the space of y. So -3x plus 3 times x plus 3 equals 4. Distributive property. Combining like terms, -3x plus 3x is 0x. Those go away. So I'm left with 9 is equal to 4. And that, my friends, is no solution. Now, if I was left with instead 4 equals 4, that's when I would say infinitely many solutions. But because I have a not true statement, not true, 9 is not equal to 4, then I have no solution. Okay, last one. What if they're both solved for y? Then I substitute this in here. So 1/3 x minus 3 is equal to -x plus 1. So basically, I'm pretty much just getting rid of the y's and setting the two expressions equal to each other. To clear the fraction, I'm going to multiply everything by 3. So this becomes x minus 9 equals -3x plus 3. I'll add 3x to both sides. I'll add 9. And x is equal to 3. Subbing that back in, y is -2. Sorry, I'm out of time in this video, so I'm not going to check my